Hi, my name is Max, and today I'm going to show you my project. I took the microcontroller course by Professor Tersteg at FH Aachen, University of Applied Sciences. My project is about a line-following car. The goal is, as the name suggests, to build a car that can follow a black line on the floor using a microcontroller. Therefore, I need a car with a motor to drive forward and a servo to stir. For detecting the black line, the car also needs two sensors that can measure the reflected light. To avoid having trouble with external light sources, I also added one LED next to each sensor to provide an even light. Whenever one of the sensors detects the black line, the car is steered in this direction. If both sensors see the black line, the car is stopped. The Texas Instruments MSP432 Launchpad is the core of the system. For the car, I used an old remote-controlled Lego car where I replaced the motor driver with the L293D as well as the old steering motor with a common servo. For detecting the reflected light, I used simple photoresistors which increase the resistance with decreasing light and vice versa. On this slide, you can see how I arranged all components. The servo is connected to a 5-volt power supply and to a PWM pin on the microcontroller. The motor driver is also connected to two PWM pins, in order to be able to change the direction and speed of the motor. I connected the two channels of the motor driver in parallel to increase the maximum current. To provide power for the motor, 5 AA batteries are needed. The LEDs and photoresistors are connected to a 3.3 volt power supply, whereby there is a resistor between each photoresistor and the ground, establishing voltage dividers. In the middle of these voltage dividers, I connected analog to digital converters. This alternative schema provides a more detailed view of the circuit. You can see the voltage dividers that are used to read the photoresistor measurements. You should also recognize the parallel connection of the two motor driver channels. Here you can get a small impression of the progress. I unsoldered some old components. In order to reduce the complexity and be more flexible, I used a breadboard instead of soldering the new components together. I still spent quite some time on plugging cables in and out, until it finally worked. The rest of the time, I implemented the drive logic using C++ and the YAHAL abstraction layer. Let's have a look at the results. Pretty good, right? Thanks a lot for listening. I hope you enjoyed the video.